So who here has built a questionable re-engagement campaign? Only a couple people brave enough to say that. Yeah, so I think a lot of us have seen these and or had to build these at various points in our careers. So these are 3 examples of, I think, my favorite type of push notifications to get. And I was so happy during Britt's talk that she led with that JOMO FOMO thing because I knew this slide was coming up right afterwards. So these work, a little bit, right? These do get people to click back into an application, but they kind of have a problem. One, they're tacky, they're not really relevant to what I'm doing today. And as a user, like, if I get enough of these from an app, that's gonna go into the uninstall bucket pretty quickly. But what problem were they trying to solve? Like, why did these apps build these? And we've all seen push notifications like this. So if we go look at our activation funnel, like at first, a user is going to have to install our application, and they're going to have to do something to activate, probably do some registration step. And then we enter this part of the funnel where we have engagement. I think we're all pretty familiar with this in San Francisco, but engagement is how often a user comes back and uses our application again. Right, so we can have a really tight engagement loop. We can have a user coming back, every 6 hours because they're getting tons of value from our application. We could have a user that comes back once every couple days, or maybe for a different application, a user coming back once a month is sufficient, and that user is completely engaged in our application. But sometimes stuff happens, right? Life happens, maybe you don't need the application for a month, or you go on vacation and you forget to launch it again when you come back, and then it's something you never launch again. And that's when we have this problem where a user stops being an engaged user. It becomes a churned user. And we want to remind the user of the value of our application when this happens, right? So that's what re-engagement is. That's fundamentally what problem these push notifications are trying to solve. And in this talk, I'm going to talk about some effective ways to do re-engagement that are a little bit less tacky and a little bit more focused on what the user is trying to accomplish than a push notification telling them that their friends are doing stuff. Then after I talk about re-engagement, I'm going to talk about some friction steps that happen on Android for most applications and ways to address those. So let's jump into re-engagement. The big way we're going to talk about re-engagement is slices. So slices is a new Jetpack library, and I want to lead very clearly. So slices is currently being worked on. It's not available for general availability yet, so you can't actually make a slice, get it out there today. That's going to be happening early next year. But I want to just be very, very clear about that because I think there was some confusion about whether slices was out or not. So a slice is basically a mini snippet of your application. It's just a small little surface of your application that allows the user to interact with some core functionality of your application. So in this slice here, it's for a music player like maybe Google Play Music. The user can go forward, back, they can pause, play the song, or select a song or heart a song, right? So they can do all of these actions from the slice without actually launching the application. This is a fantastic way if the user wants to interact with your application kind of in a very casual way to get them kind of thinking about coming back to using your application. And then once you build a slice, it can be used in, for example, the Android Google Search app or perhaps the Assistant, right? So these are 2 different surfaces where the slice might show up when the user is trying to accomplish a task. So here, the user is looking for music, and the music slice shows up. It's exactly the thing the user is looking for, and it's very likely the user is going to be happy to be engaged by that slice. So taking a step back, what makes a good re-engagement campaign? So all good re-engagement campaigns kind of have the same 3 things in common, right? They're relevant to a user. There's something that a user actually wants to do. It's a user wants to actually play music. A user actually wants to look at photos right now. Maybe they want to actually book a cab right now or find a restaurant right now. These are things that a user is trying to accomplish right now, and you're relevant to the task that they're trying to accomplish. It's also timely, right? So I try to book a cab, I booked a cab this morning on the way here, and I care about cabs when I'm doing that. Right now, I don't care about cabs. I'm on stage giving a talk. So it's not always easy to guess when a user wants a notification, when they want to be told about your application. So this is something that slices can really help with. And then it's also actionable, right? If I get a push notification and all it does is maybe do some brand marketing and remind me the application exists, that's very likely to not be helpful. That's not likely to lead to any sort of positive metric gain at all. But if it's actionable, like that music slice I showed, where I can go ahead and play the music and start actually interacting with the application and getting the value from it, that's something that's going to be substantially more likely to actually have an impact on your application. And so this one right here, this re-engagement campaign meets all of those criteria. So it's timely, it's relevant because I'm looking for music right now, and it's actionable. It lets me actually do something. So there's a couple different types of slices that we've envisioned that people might want to use. And of course, you might come up with new interesting ones that are highly successful too. The big one that we have a lot of success with internally is quick access, right? So I'm looking for home, and I'm going to go ahead and get this Google Maps slice, which is going to go ahead and show me all of the places that I might want to go. And then when I click those, I'm going to open the Google Maps app, for example. Inline tasks, so this is something where if your application has a small little critical path that the user commonly interacts with, they might be able to do that all inside of a slice. A music player is a really, really good example of this, where what we do in a music player typically is play music. So it's pretty easy to kind of encapsulate that into a small UI surface. And then discovery. So this is going into a little bit more of, maybe a little bit more marketing style. So if I do discovery, I may be looking for videos, and the YouTube app, for example, may go ahead and do some discovery. It may go, this user is interested in this kind of content. Let me go ahead and show them a discovery content for that. Or recall. This is something that is wildly successful if it's something your app can do. So recall basically means the user's interacted with content before. You have metrics that you know this user is happy with it, and you're going to show this content to the user again to remind them of the value of your application. So there's a couple guidelines for how to design a slice that I just want to jump through and talk about what makes a good slice, what makes a bad slice. The simplest guideline right here is focus on one task, right? So focus on exactly what the user's trying to do. So here, the do slice shows one task. It has just a few options. And this don't slide is probably my favorite example slice I've ever seen. This is the slice, I like to call this the slice with two marketing departments. So there was one marketing department that was like, hey, we're going to go ahead and show the keynote. This user's probably going to be really happy with that. And then the other marketing department jumped in at the last second and said, wait, we need to put channels on that. Don't worry, the user's going to love it. It's going to be great. So this is a kind of an anti-pattern, right? When you start showing tons of content to the user in a slice, they're interacting with this in a very ephemeral way. They're probably not going to want something busy with lots of different kinds of content on it. On this one, this is just kind of basic design, right? So we want to keep our slices simple. Again, these are very ephemeral, right? You're in the middle of a Google search. Maybe you're interacting with the assistant. These are very lightweight activities. So you want to keep your UI surface really, really simple and to the point. You want to minimize the number of controls you show the user. This one's really, really easy to understand what all of these buttons do. And you could just like looking at this without playing with it, I'm sure all of you know exactly what clicking on every part of that slice does. This one over here, also easy to understand. I'm not exactly sure what the thumbs up, thumb down thing is, but you can figure out what's going on there, but it's a little bit too complicated. And if I scan that really quickly in a search result, I'm going to be probably overwhelmed with the number of buttons that I'm seeing. And then the other thing is just make sure the user can actually accomplish what they're trying to do, right? They're in the middle of this ephemeral activity, so let them go to the next song, pause the song, play the song, or whatever. Don't just show them the currently playing song, right? That's not a really good use for a slice. Similarly, this maybe Nest, for example, might make a temperature slice. You probably don't want to make a slice that only lets you raise the temperature. That would be very hot. That's not a great slice. So you want to make sure the user can accomplish all of the critical tasks that they are trying to do. So now I want to segue out of the do's and don'ts and talk about how to actually build slices. And I'm going to focus primarily on the UI part of slices for this talk. So slices in Kotlin are actually defined with a DSL. So all slices start with a list. So all slices start with a list of rows. So here I've defined a list, and I've given it a timeout of infinity. And that means when someone gets this slice, when Android Google Search App gets this slice, it's going to cache that slice for forever. And it's going to assume that slice is correct forever. You can set that to a lower timeout, and if your content has if it has a life cycle, you want to make sure that you set that to an appropriate cache duration. And Google Search will extensively cache these. So just be aware that you will probably have a cached slice served. So make sure your timeouts are correct. So once you have this list, we can go ahead and add a header to it. So a header row is actually a really good idea to add one to every slice. And it's the first row of a slice, and it's the simplest row. So a header can have a title as well as a subtitle. And it can have a primary action. So the primary action is what happens when you click anywhere on the slice. And that's probably either gonna send a broadcast receiver to your application to do something, or more likely that's gonna open up an activity in your application. You can do both of those. You have full control over what that intent does. And then you can give it extra actions that go on the right. So here we're gonna add a star and we're gonna add a diamond. And then we can also, instead of a header row, we can make a regular row. So the difference between these is the header row has a little bit of a bigger font and a little bit more of a restrained design surface. You can only add the things that I showed you. So the row also has a title. It has a smaller font for that title. And a subtitle. And then this is where there's a big difference. So we can have a title item, which is the thing that happens at the start of a row. So we can give it a timestamp, and it's going to get a human-readable timestamp like that. Or we can give it an icon. We can tell it to display a star. And we can set end items on this as well. So we can actually put quite a bit into a row that we add to our slice. And another thing you can do with slices, so we've looked at buttons so far. So these buttons are probably going to trigger a broadcast receiver, or they're going to trigger opening an activity in your application. You can also add a toggle here as well. Toggle is going to go in, and it's going to act like a toggle. So it's going to update the UI immediately, and then it's going to tell your application about the updated state. So it's a little bit different than a button, which has to do a round trip to change the state. So there's one more type of row that I'll cover in just a minute, but we already have enough to build an engaging slice. So if we start with just a header row, and I'm going to add a header, I'm going to add a title and a subtitle, and I'm going to give it some actions, and these are just clickable icons, and then we'll add some rows with static images on them. And then I'm just going to add some end stuff to that. I'm going to add some icons. They're all clickable, and these are actually toggles here because I want them to update the UI. These hearts should get filled immediately when the user presses the button. And then if I build that, this is actually going to be that slice that I demoed at the beginning. So that's a fairly rich design surface available without that many elements to learn. It's not that hard to use. This brings up an interesting and important thing to know when you're designing slices. So slices are very much controlled by the surface that's displaying them. You're just describing what you would like, but the surface that's displaying them may not have space for a scrollable multi-line slice. It may have space for a single line slice. And if that happens, your first row is going to be displayed, and the rest of it's just not going to happen. So you need to design for that when you make your slice. You need to think about, this slice may be displayed as a single line slice. So this brings up this gets us to the last type of row you can add to a slice. So this is the grid right here. So this is the most versatile of the rows that you can add. And by using rows and grids together, you can get a variety of different layouts. So when I add a grid, I can add a single image to that, for example. And if I make it a large image, that's how I get that hero image that we saw in a couple of the example slices. This is going to be taller than a normal image. It's going to fill the entire screen. If I add another one, I'm going to go ahead and divide the space equally, right? It's a grid layout. I can add a third, a fourth, and then if I want to add a fifth, it won't actually let me add a fifth large image. But I can switch that out for small images, and now I have the ability to make 5 images. So I might use 5 images if I want to show one of that photos slide where I did a recall where I'm trying to show a large collection of things with 113 more. That's something I might use small images for. If I just have one piece of content like that YouTube recall thing, I might want to just use a hero image and be like, hey, I got this giant image, do you want to click on it? A cell can also have text and title text. So once we do that, I can actually build some interesting layouts that we'll see in a second. If I add a couple of these, they're just going to lay out beside each other. And then the other thing a grid can do is you can mix these, right? So you can add a large image and a small image, some text, some more text, and then another small image. Right, so this is the one place in slices that you have a lot of design freedom, which is good because you can build some great UIs, but I'm hoping this one doesn't actually make it to production in any of our apps. So let's go ahead and put that all together and review just some of the example slices that I talked about and talk about what goes into designing them. Right, so here's one that we showed earlier where making material design from Google Design. So this is maybe a YouTube slice, right? So we can see that top there, right there, that there's a header row. It has that large text and then a subtitle, and then it has 3 actions over there on the end. Then in the middle, we wanted a hero image, so we used a grid with 1 large image in it. And then at the bottom, that's just a row with a title and a subtitle and no actions. Right, so that's all that goes into making that slice. And you define that all with the Kotlin DSL. This is another example. This one's a little bit more complicated to build, actually. So here, we still have a header. It has a title, it has a subtitle, has 1 action to share over there. And then we have this grid of 5 small images here. So the first 4 images are pretty simple, but then we have this plus 115 right here. So in order to actually do that, someone has to raster that onto that image. So slices don't have an API to put text on top of an image. So you'll either have to do that in your Android app using some sort of drawing, or you're going to have to do that on your back end and then download the image in order to display it in your slice. And then this one right here is very similar to the first one. So the header row is very much the same, right? So we have the header row, then we have the subtitle. And this is going to look very similar. Almost every slice I've seen starts with that. And then 1 or 2 actions over on the right. Then we have the large hero grid again. And then down at the bottom, we use another grid in order to show a contrast between a start and an end. You might use it here, for example. This is a hotel booking, for example. You might use it for a cab trip or something like that as well. And then there's one more thing that you really do need to be aware of, especially when you're working with your designer. The app that displays your slice controls the accent color. You don't have any control over this at all. So it turns out Android Google Search uses a nice neutral gray that makes designers happy. But in theory, it could be a bright, bold color. So this is something that's worth testing specifically with the surface that you're targeting. And you should make your designers aware that the accent color is going to be applied to the icons and a couple other places. And so if the surface that you're displaying is using a bright accent color and you're also using a bright different color, that could be a problem, right? That can end up clashing. So originally at this here, I went through an implementation section. I wrote like a 5-minute talk about like each line of code, and I practiced it this weekend, and I realized I was doing a dramatic reading of the documentation, which is an exciting talk, but that's maybe a different talk. I'll submit that next year, dramatic reading of documentation. What I'm gonna do is I'm gonna do one slide right here to just cover the basics of what you need in order to actually build a slice in the rest of the code, right? So we've talked about the DSL, that defines the UI part, that defines your slice. So how does that actually work? How does that DSL get triggered? So when the Google Search app would like a slice, what it's going to do is it's going to call onBind slice to a slice provider. So a slice provider is just a content provider. You define it in your manifest just like a normal content provider. And it handles this one overload method is the important one. There's a couple other overloads, but this one is the one that actually returns the slice. So here's where you put the DSL to actually define what content you'd like the Google Search app to display. It's very important that this be very fast. This could get called in the critical path to displaying your slice. So you don't want to do a database query. You should treat it like the UI thread. You don't want to do a network call before you return the slice. If you do have to do those, you should just return a preview slice that holds the space, and then do the long task, and then tell it to update the UI later. Then later, the user's going to go ahead and click that play button. And when that happens, because you configured it, it's going to go ahead and send a broadcast over to your broadcast receiver that you also defined. You set all of this up in code as well. The broadcast receiver is going to do stuff. It's going to start playing music. And then it's going to go ahead and notify that there's been a change to this URI. So all that causes to happen is the slice host is going to go ahead and call onBind slice again. And this pattern right here is the core to understanding how to build all of the UI slices that I've talked about so far. And what's really important here is that notify change. Again, if you have a long-running task, if you're going to touch the database, if you're going to touch the network, that notify change is how you fill in from a preview slice to a fully, a slice that has all of the data. And that's really all you need to know, right? So the rest of it is in the documentation for all the details about how to make all this work. But these are the two main components that you need to do. The other thing to note is you could, for example, actually, instead of sending a broadcast, you could configure it to open an activity as well, or any intent you can think of. You can open a web page if you want to. So that ends what I'm going to talk about for slices. But actually, it turns out there's this really interesting thing I had on the screen earlier. I'm just going to add a little section right here. We're going to talk a little bit about that slices DSL. We're going to talk about how that got implemented and a little bit about DSLs as an API design. This is something that's really exciting coming into Kotlin, and we're excited about being able to use this to build great APIs as well. So if we look at how that works, so we actually have two different slice builder APIs. So over in the Java programming language, we use the builder pattern, just like you would expect, right? So the builder pattern lets us make a list builder, and then we can set a header on it, and then we use a header builder, and then we go ahead and set the title and the subtitle. Right, so we're all familiar with this. We've been doing code like this since, I don't know, like 2003. So the builder pattern's like pretty stable. We're all pretty happy with it. Over in the Kotlin side, we have a much more succinct syntax. And so we call syntax like this a DSL. And I really thought a bit about like how I wanted to define a DSL for this talk, because in Kotlin, I think DSLs are a little different than other languages. The way I think about a DSL in Kotlin is it's an API that uses language syntax as part of expressing the API. So when you look at this thing over in the DSL side, we're using these curly brackets as part of the API, instead of just this thing that you're maybe using ifs or whiles, and then you're just calling functions. So that's the big difference between what makes a simple API or a regular API and something that moves into the DSL category in Kotlin. So let's go ahead and take a look at how to implement that DSL. So we started, when we first wrote slices, we started with this builder pattern here. We had a Java programming language implementation of this builder pattern. And we were looking at what's the best Kotlin API to build. So we took this builder pattern and we built that DSL from it. And this is a pretty good pattern for building DSLs in Kotlin. So I'm going to go ahead and walk through how to build syntax like that in Kotlin. So the first thing I'm going to do is define a function called list that has a lambda argument, add rows. Now, if you're familiar with Kotlin, this lambda argument here is basically it's a function pointer. So it's pointing at some function somewhere. It can point at a lambda, which is what we're doing over here on the right. And the lambda is all of the stuff between those two curly brackets. Kotlin lets us move the lambda outside of the parentheses if it's the last argument of a function. And we're going to use that syntax feature pretty extensively to build this DSL. And since all the other arguments aren't really relevant to what I'm talking about, I'm going to hide those for the rest of this section. The next thing that we're going to do is we're going to take that lambda and we're going to make it what I call an extension lambda, or in the documentation sometimes it's called a lambda with receiver. So this is actually a little bit different than a regular lambda. So a regular lambda is just a function that you can hold a reference to. This here is a lambda with receivers. So it has an implicit this argument that is of type list builder. So it's as if this code block right here is a member method on list builder. So it's going to have an implicit this argument. And we're going to use that in order to build the rest of the DSL. Then inside, we're just going to go ahead and call through to the other builder that we had before. And this is a common pattern in any DSL in Kotlin, right? You start with a function, and then you call through to a builder. So here we're going to go ahead and make a list builder, call it builder, and then we're going to call that add rows function. Right, so add rows is not actually a member variable on builder, right? So to understand what's going on here syntax-wise, add rows is it's a parameter to this function that's anything that could be a member method to a list builder. And then I'm going to apply that variable to the builder object. Then when I go over here, now I have access to all of the parameters and functions, or sorry, all of the functions and all of the properties of the list builder. Then to go further, now I'd like to make that header builder as well. So I need to make another step to this DSL. Now I'm going to take list builder, and I'm going to extend it to have a header method on it. And so that's what we're actually calling over here on the right. We're saying listBuilder.header. Because again, listBuilder is the implicit this argument inside that Lambda. And that's also gonna take a, one of those Lambda with receivers. It's gonna take a extension Lambda. Inside this header function, we're gonna go ahead and call setHeader on the builder right here. So this is calling setHeader on listBuilder itself. And then we're gonna apply that Lambda, the build header, and that's gonna get us into this area here, which is gonna let us call, on this one argument, title and subtitle. And these are gonna go ahead and pass through to set title and set subtitle on the on the header builder class itself. Right, so now I've taken this builder class implemented in the Java programming language, and I've translated over to a DSL in Kotlin. So this allows us to build substantially more succinct APIs in Kotlin. There's one problem with it, though. So the implementation that we've done so far allows me to call header still, right? So I can still call either explicitly or implicitly, I can say this header. And when I do that, it compiles and it runs, but that's not a thing I actually want to be allowed to do, right? So I don't want to be able to put a header inside of a header. What I really want to do is turn that into a compiler error by getting rid of one of those this pointers. So let's go ahead and figure out how to do that. So Kotlin has an annotation called DSL marker that's for exactly this. It's literally just for allowing you to construct DSLs that allow you to build tree structures like this. So if I make a new annotation slice marker and I annotate that with DSL marker, I can then create a list builder DSL, which is a subclass of list builder, and annotate that with slice marker, and the same thing with the header builder as well. Right, so now I've created two classes that are just literal pass-through subclasses to the builders that we had in the Java programming language. And if I go down to the bottom here and I update all of my classes to use the DSL version that I've defined over in Kotlin, now I'm gonna go ahead and get that error message that I was hoping for, and we've created a happy little error message and we get a compiler failure. So when to use DSLs? So I think that in this case, and we went through API review and it went out, it's production API. I think that in slices, DSLs are a really good addition to the API. There's another API we made at the same time that we considered a DSL for. We looked at Work Manager. It also, we shipped with a builder pattern. It's also part of Jetpack. We did make a prototype DSL for Work Manager for simplifying the usage when you went through the through the builder pattern. And that did not get shipped. And the reason for that is we found that DSLs, they're great, they're succinct, and they read really, really well when you're doing tree type things, when you're defining declarative UIs, right? This is a really natural fit for a DSL. In Work Manager, we were really just changing a builder into a DSL because we kind of could. And it didn't improve the readability of the API. Like there was no actual gain to the user in reading this Work Manager DSL versus reading a Work Manager builder. Simultaneously, DSLs also have a problem in Kotlin compared to maybe a builder pattern, that they have less discoverability. So if I'm a user and I have a builder object and I type dot, I get all the functions I can call. If I'm in a DSL, there's a little bit less of a discoverability going on there. So in the case of the Work Manager DSL, we found that discoverability problem was larger than any gains for readability or usage. So the way that I think about it is DSLs are a really good fit if the user would naturally expect a DSL to be there, if it seems like a really good idea. But if you're just using a DSL instead of a builder, maybe the builder is actually still the right pattern to use. All right, so for the last part of this talk, I want to talk about a couple ways to reduce friction. So slices, again, they're not in GA yet, right? So they're not something you can actually ship in your application. So I wanted to talk a little bit about stuff you can actually go do today that'll help move some of your business metrics up. So there's this thing that happens on Android, and well, all mobile phones, that users buy new phones. Who here has bought a new phone in the last 4 years? That's everyone. Who's bought a new phone in the last 2 years? That's still everyone. So in this room, every single one of you has bought a new phone in the last 2 years. What that means is all of the apps you use, they've had every single one of you is getting a new phone, or sorry, half of you are getting a new phone every year, right? So if you think about that, if everyone gets a new phone every 2 years, that means every year half of your users are getting a new phone as well. And so there's this really problematic thing that happens when that happens. One of the things that can cause this engagement gap is you could get a new phone. And when you do that, Google Play is going to go ahead and reinstall your application, but if you don't do anything, it's not actually going to create a great experience for that user on the first launch, and they may bounce from that friction. So by default, it's going to go ahead and create what I call a cold welcome. Right? You're going to just show up, and you're going to pop up an email and a password dialog. Who here remembers all of their passwords? Nobody. So the users are the same, right? All of our users are the same way. So we show a password dialog to someone who's maybe casually used our app for the last 2 years. There's a good chance they're going to have to either use the forgot password button, or maybe they're not going to bother. They're not going to actually come back into our application. Instead, what you really want to be doing when they get a new phone is you want to create a continuity of experience, right? You want to go ahead and tell them, oh, I know that you were using this application before, and I'm going to help you get back in. I'm going to either automatically get you back in, or I'm going to take steps to make that easier for you. So the easiest way to do this, and the best way, if it's possible for your application, is to use Google Sign-In or federated auth, right? If you're showing a password button, that's a huge friction barrier to the user. Right? The user has to go remember their password, use the forgot password flow, hope that works, and go through all of these steps. Google Sign-In, it's a single button, you click it. So that's going to help you because you're going to get a lift in activation and engagement right away, because it's just easier to log in with Google Sign-In than it is to make a new account. And then simultaneously, when they get a new phone, it's really, really easy to sign in again, right? So all they have to do is click that button, go through some prompts maybe, and then they're going to go ahead and end in the application. And on Android, you can even configure Google Sign-In so that it will automatically log them back in if they've logged in on the same Google account to their phone. So Google Sign-In is a federated login, and you can use it on Android, obviously. You can also use it on iOS, and you can use it on web as well. Another feature you can use is Smart Lock for passwords. So Smart Lock for passwords I like to just call it a password manager. So what it does, it just stores an email address and a password, or it stores a federated auth token if they logged in with Google Sign-In. And the way that works is the user will get a prompt after they log in saying, would you like to store your password with Smart Lock? And if they hit that save button, it's going to go ahead and store that up in a secure password manager. And then when they come back to your application on the new phone, they're going to go ahead and get a prompt asking them if they'd like to log back in again. Or if there's only one login, it might just automatically log in and let them know what happened. One of our partners, Netflix, used Smart Lock for passwords, and when they did that, they found they got 20% fewer support requests. So that's huge, right? So 20% fewer support requests related to login. That's huge in both, that's just a lot of support requests. It takes a lot of effort to respond to all of that. But simultaneously, that's 20% of the users who were having trouble getting back into your application, not having trouble and having this enjoyable continuous experience, right? So that's really, really good for making your users happy as well as business metrics as well. Another thing that we launched is Android autofill. So this is starting to roll out. It's now covering a large portion of the ecosystem. It works very similar to Smart Lock when it comes to passwords. And it actually turns out the most common thing that gets autofilled is usernames and passwords. So the way autofill works is after the user logs in, they'll get prompted, do you want to save that to whatever the autofill provider is? It could be autofill with Google, it could be LastPass, it could be the one from Samsung, for example. But it's going to go ahead and save that up to a secure password manager. And then when they come back, they're going to go ahead and they'll click the text box, and when it'll prompt them to autofill the text box. There's one thing that you should do in order to get autofill to behave even better, which is set up a digital asset link. So a digital asset link is something you've probably already done for deep links, but it allows you to share that credential between the web browser and your Android device. So this can create this amazing user experience where the user logs in with Chrome and then saves their password using the autofill provider or their password manager. And then on Android, they have the same autofill provider or password manager. And when they get to Android, they click the username button, and their username and password sitting there ready for them on Android. The other thing that you should really do, and you should definitely do that if you haven't done it yet, is set up your autofill hints on your key app flows. So autofill hints tell the autofill service what type of field it is, right? It says this is a password password field, this is an email address, or it says this is not important for autofill, please don't use it for autofill. You might use that for a CAPTCHA, or I don't know, if you had a spreadsheet in your application, you wouldn't want autofill on that spreadsheet, for example. So autofill hints tell the autofill service explicitly what your views are. If you don't explicitly tell the autofill service what your views are, it's gonna try to guess. They do a pretty good job, but you probably don't want your business metrics resting on someone else's app guessing correctly what your views do. So it's a really good idea to, especially in your login forms, make sure that these are set up. And then the last thing you can do is set up auto backup and configure that. So auto backup allows you to transfer files from the user's old device to the new device. So Gmail uses a similar system because they have this Nux prompt that happens when you go into Gmail the first time. It says like, welcome to Gmail, like, and it's a little carousel or something. And I think we've all built something like this, and these are great for the first time you see them, but like the second, third, fourth, fifth time you see it as a user, they start to get pretty stale. And Gmail had a goal of only showing this to each user exactly once. And so this is a way to do that, right? We show it on the old phone, and we definitely don't want to show that on the new phone. So the way auto backup works is up to 25 megabytes can be backed up once a day or so. It's going to be when the phone's charging, when it's on Wi-Fi, that sort of stuff. But it tries to do it about once a day. It's going to back up all the files of your application that you tell it to about once a day. And then when the user gets a new phone, it's going to download that at the same time as it downloads the APK to install it. And then it's going to overlay the files on the file system before the first launch of your application. And it's really important when you configure auto backup that you configure include and exclude rules, right? So the include rules and exclude rules are all configured in your Android manifest. Things that you don't want to store in autofill. You don't want to store, auto backup. You don't want to store passwords. You don't want to store anything sensitive about the user at all. You don't want to store that sort of content. It's great for hiding a Nux prompt the second time, or configuring configuring some part of your application, but it's not a place to store sensitive data about the user. And that's all I have for you today. Does anyone have any questions? Yeah, so I'll repeat the question. Would we build the Kotlin DSL differently if we weren't starting from a Java builder? And one of the constraints we have, we support both, right? So we make APIs for the Java programming language and Kotlin at the same time. I don't think so. I think maybe we would have written the code of the builder differently in Kotlin if it was there, but the builder really helps clean up the DSL implementation. It gives you this base that you can work from, and then the DSL is just syntax sugar on top of that. If you write your builders in Kotlin, you can even think about that as your Java API as well, right? Because you can export the builder to the Java programming language very easy, but exporting all of those Lambda functions is somewhat hard to do to the Java programming language. I saw another question. Yeah. Oh, so have you seen, there's an HTML DSL that JetBrains put together. That's another example of, the way I kind of think of it is like, if I might declare this with JSON or XML, a DSL is probably also a good fit. There's an HTML DSL. There's a Gradle DSL, which is effectively calls out to Gradle. Those sort of things as well. Is it possible to add maps into slices? Not currently, no. That would be a great feature request, though. b.android.com, and then just put it in the Jetpack component. It's a great idea. Our slice is going to replace widgets. I think to be determined on that one, to be honest with you, I'm not actually sure how that one will play out over the next couple of years. They're not currently. Can slices be used to show notifications? No, so the notifications API is different than the slices API. So the slices API is going to be, in the initial GA, is going to be heavily focused on Android Google search, and then later on Assistant as well. Yeah. Our slices constrained to a form factor of device. So your Android app code has to be running. So they're constrained to devices that have the Android operating system underneath. Is there any way to do a remote kind of thing? No, I can't. I can't think of like any bridging that I can come up with there. Yeah. So how will slices be prioritized to the end user? So the key there, really, it's like, especially in like the Google search surface, it's about what's going to get clicked the most. What does the user actually want to interact with? And that's always the goal with all of that. So tricks to do that, basically, is make sure, when you make a slice, make sure it's highly relevant to the user. You're not just like flooding it with every keyword you can think of. You're targeting specific things that you have a high expectation that the user actually cares about. That's why the recall slice is always a really good thing to take a look at. Like, if you have data that this particular user is happy with this content, that's a great piece of content to show them again. They're likely to interact with it again or stop showing it to them.